Welcome to tonight's video on Unit 3, Part 3. We're talking about basic derivative rules. The first derivative rule is that the derivative of a constant is equal to 0. In other words, this says the derivative of a constant is 0. And why does this make sense? Well, the slope of a horizontal line is 0. And whenever you take the equation y equals a constant is a horizontal line. So therefore, when you take the derivative, the slope will be 0. So when you find the derivative here, y equals 7, y prime is 0. F of x equals -3, f prime of x equals 0. P of r equals 4, p prime of r equals 0. G of t equals k e to the third pi. Well, notice there's no t there, so this is a constant, so g prime of t equals 0. Using the definition of derivative, prove the constant rule. Well, remember, the limit as h approaches 0 of f of x plus h minus f of x all over h is the definition of the derivative. If f of x equals c, then f of x plus h is also c. So basically, you have the limit as h approaches 0 of c minus c over h. So then you have 0 over h, which is 0. So the limit as h approaches 0 of 0 is 0. The next rule is the power rule. Notice that basically the derivative of x to the third is 3x squared. The derivative of x to the seventh is 7x to the sixth. So notice basically you subtract 1 from the power and multiply the power by the front. So for example here, the derivative of x to the n is n times x to the n minus 1. In other words, you multiply by the power and subtract the exponent by 1. Right, so x to the n is n times x to the n minus 1. So for example, the derivative of x to the 15th is 15 x to the 14th. So whenever you have a radical, remember, whenever you have the square root of x, it's x to the 1/2 power, right? So whatever radical you have, x to the power is equal to its power over root. So here, this would be x to the 1/4. The derivative is then 1/4 x to the -3/4, because 1/4 times minus 1. Then, to make it a positive exponent, we move it to the bottom of the fraction and make it 1/4 x to the 3/4. That is your derivative. So here, rewriting this is r to the -5th. So then when you take the derivative, it's -5r to the -6, which means it's -5 over r to the 6th. This last one here, when you rewrite it as a fractional exponent, it's t to the -2/3. So then g prime of t is equal to -2/3 t to the -5/3. because negative 2/3 minus 1. So therefore it's negative 2 over 3t to the 5/3. If f of x equals x, then f prime of x is equal to 1, because if you think about it, if f of x equals x, right, well, the power is 1, right, and then 1 minus 1 is 0. So 1x to the 0 is 1. Also, the slope of a line in the y equals mx plus b is the m, right? In this case, the m is 1. All right, we'll skip the proof of the power rule. Go to the constant multiple rule. So the constant multiple rule says if there's a constant already in front of the power, that you multiply the power by the constant and then subtract 1. So c, the derivative of c times f of x is c times the derivative of f of x, or basically c times f prime of x. So the derivative of a constant times a function is the constant times the derivative of the function. So in this case, here, we'll rewrite this as y equals 5/3 x to the negative 4th. So to find the derivative, you're going to take negative 4 times 5/3, which is negative 20/3. And then negative 4 minus 1 is negative 5. So the derivative is negative 20 over 3x to the 5th, because you move the x to the negative 5th to the bottom of the fraction to make it positive. Here, s of t is equal to negative 4/3 t to the negative 3/5. So then it becomes basically you cancel because negative 4/3 times negative 3/5, you cancel there, and the negatives cancel out, so it's 4/5 t, and then negative 3/5 minus 1 is negative 8/5, so it's going to be 4 over 5t to the 8/5. Final answer for the derivative. So here, the next one, rewriting it, so s of t is equal to 7t to the 2/5. So the derivative is equal to 14/5 t to the negative 3/5, because 2/5 minus 1. But then to make the exponents positive, it would be 14 over 5t to the 3/5. So here, once again, it's negative 4/3 t to the negative 3/5. And then this becomes 4/5 t to the negative 8/5. So it becomes 4 over 5t to the 8/5. All right, sum and difference rule. So basically, if you're adding two functions together, it's the derivative of the first plus the derivative of the second. Or minus, depending upon what you're going to do is the derivative of the first plus or minus the derivative of the second. So here, for example, if you have f of x equals 4x to the fifth minus 3x plus 7, you're just going to take the derivative of each one individually. So this would be 20x to the fourth minus 3, and this would be a 0, so you just leave it out. If you have a product here, I would distribute it first. So y equals x to the fifth minus 2x squared. Then I would take the derivative, so it's 5x to the fourth minus 4x. Here, I would rewrite this, so it's 1/2 r to the negative 1/2 power. So then when you multiply to get the derivative, negative 1/2 and negative 1/2 is negative 1/4. Negative 1/2 minus 1 is negative 3/2. This is a constant, so it basically goes away. So then it just becomes negative 1/4 r to the 3/2. For g of x equals 3x to the negative fourth plus t, this is a constant. So the derivative is just going to be negative 12 x to the negative fifth, which is negative 12 over x to the fifth. So next, the derivative of the sine, that would be the cosine, and the derivative of the cosine is negative sine. If you think about it graphically, right, here's the sine. The sine is, if you think of the graph, the sine goes like this. So if you think of the derivative, so this is f of x equals sine x. But if you think of the derivative, meaning the slope, notice the slope rises here, right? So it goes right here positive, and then the slope here is 0, but then it's negative, right? Negative all the way down, and then here it's 0 again, and then it goes positive. So if you look at the graph of the derivative, is, if you look at that, that's the cosine. So that's a graphical depiction of why the derivative of the sine is the cosine. And if you want to know why the cosine is negative sine, we can do the same thing. So we draw the graphs. So the cosine would look like this. That's the graph of the cosine. And if we look at, and notice it would go something like that if it kept going, right? And same thing here, if it kept going. So if we look here, the slope is 0. Here it's going to be going down, so it's negative 1. Here it's 0. Here it's going up. And then here it's at 0. So if you notice, here's the graph of the slope, which is the derivative. And notice this graph is the graph of the negative sine x, right? Because normally sine goes up, but here it's going down. So those are the graphical depictions of why those are the derivatives for sine and cosine. So finding the derivative here, so 3/2 sine x plus 2 cosine x plus 4/3 x to the negative second. So let's rewrite this so it has a positive. So it's 3/2 sine x plus 2 cosine x plus 4/3 x squared. Right? If we move this up, it becomes positive. All right, so now we can take the derivative. So it becomes, remember the derivative of the sine is, cosine, so it's going to be 3/2 cosine x. And then the derivative of the cosine, remember, is negative sine. So it's going to be 3/2 cosine x minus 2 sine x. And then it's going to be 2 times 4/3 is 8/3 x, right? Because notice 2 minus 1 is 1. So that is your derivative. Once again here, we'll do the same thing. So we have to first rewrite it. So it's -3/pi sine x minus 4x to the -3/5. Taking the derivative here, it's going to be, remember the derivative of sine is cosine, so it's just going to be -3/pi cosine x. The sign in front here doesn't change. Then -3/5 times -4 is positive 12/5 x to the -8/5. And then we're going to move that to the front or to the top, so it's 12x to the 8/5/5. So here's something to keep in mind when doing derivatives. Leave rational exponents as rationals, do not change them into radicals. No negative exponents, and multiple term derivatives that have a variable in the denominator should be combined into one term. We don't have to multiply out the denominators. So here's how we put this all together. So it says to basically find the equation of the tangent line at x equals -2, 0, or 2. Well, remember, equation of the tangent line, you need a slope and a point. So first we're going to need the derivative. So that would be 6x squared minus 3. So now when x equals -2, well, f of -2 was 2 times -2 to the third minus 3 times -2 plus 5. So it's -16 plus 6 plus 5. So it's -5. So you have the point -2, -5. But then for the slope, that would be f prime of -2. So that'd be 6 times -2 squared minus 3, which would be 21. So your equation would be y plus 5 equals 21x plus 2. That's one of them. But then when x equals 0, well, f of 0 would be positive 5. And then f prime of 0 would be -3. So it would be y minus 5 equals -3 times x minus 0. And last but not least, when x equals 2, well, f of 2 would be 2 times 2 to the third minus 3 times 2 plus 5. So it would be 16 minus 6 plus 5. It would be 15. And then the slope would be f prime of 2, which would be 6 times 2 squared minus 3. 2 squared is 4. 6 times 4 is 24. Minus 3 is 21. So the slope would be 20. So y minus 15 equals 21 times x minus 2. So those are the three equations, but using the derivative to find the slope. Yes. So the last one here, find the equation of a tangent line if the function is g of x equals negative 3 sine x. Well, remember, the derivative of sine is cosine, so this is 3 cosine x. So when x equals 0, g of 0, well, 3 times the sine of 0. Well, the sine of 0 is 0, so basically it's 0, 0. And g prime of 0, well, 3 times the cosine of 0. The cosine of 0, remember, is 1, so it's 3. So it's going to be y minus 0 equals 3 times x minus 0. And last but not least, basically, for the next one, when x equals pi over 6, so g of pi over 6 equals 3 times the sine of pi over 6. Well, the sine of pi over 6 is 1/2. 3 times 1/2 is 3/2. So the point is pi over 6, comma 3/2. The slope, g prime of pi over 6 equals 3 times the cosine of pi over 6, which is 3 times the square root of 3 over 2, which is 3 rad 3 over 2. So therefore, it is y minus 3/2 equals 3 rad 3 over 2 times x minus pi over 6. That is. So those are your two equations given those two x coordinates. All right. I hope you enjoyed the video, and I will see you in class. Have a good evening.